So here's the binomial expansion theorem. There's a bunch of math mumbo jumbo there that I'm not sure you need to worry too much about. Here's where we talk about if I have, and the binomial expansion is talking about having two things inside. But if I don't, like in the case of the example we just used with the kids, if I don't have any kids, that has to be by definition anything to the 0 power is 1, right? Now if we look at Pascal's triangle, that has a 1 at the very top of it. What's x plus y to the first power? X plus y. What are the coefficients in front of x and y? What's x plus y squared? What? Please don't tell me x squared plus y squared. What do you get?
X squared plus x.
If you need to, off to the side, x plus y. So x times x is x squared. Y times y is y squared. But what happens for the middle term? Your y? 2xy. So what are your coefficients in that green row? 1, 2, 1. How about x plus y cubed? You could take your answer from above and just multiply by another x plus y and add like terms. I guess my thing would be, you guys probably are starting to see it's going to be x cubed, x squared y, then it'll be x y squared, and then it will be y cubed. What would the missing numbers be? It might be a little early to see it in Pascal's triangle, but if you work with Pascal's triangle, that pattern is easy. That pattern is going to go 1, 3, 3. I guess I don't need to write the 1. So that is your next one when you have a cubic or this x plus y cubed. So it goes 1, 3, 3, 1. Let's do x plus y to the 4th power. Can anybody in here now tell me what the x's and y's, just the x's and y's, what kind of pattern are you going to see? Have you figured it out yet? X to the 4th. Don't worry about the numbers. Just give me the x's and y's. What's the next? Then if this is x to the 4th, the next term is what? X cubed. The x goes down 1, and then we begin to add the y, right? So what's next? X squared, y squared. What's next? Xy cubed, and then y to the 4th. Now, can anybody look at Pascal's triangle and start to figure out the pattern in Pascal's triangle? What? How do you know that? Can you look at the pattern and tell me how I would get those numbers from Pascal's triangle?
3 plus 3 is 6.
It does go 1, 4, 6, 4, 1. These are all added together. What did you do? 3 plus 3 is 6. 1 plus 3 is 4. 3 plus 1 is 4. Always a 1 on the outside. So Pascal's triangle will always have a 1 in the first space and the last space. And then what you do is you take the two numbers in the row above it, add them together, and they go in the middle on the next row. 1 plus 1 is 2. And then now I have the green row. Put a 1 in front for the blues. and I go 1 plus 2 is 3, and 2 plus 1 is 3. So at any point, you can get Pascal's triangle. Please understand, though, that 0, remember the 0 power? The first row is the power of 0. It is, in a sense, 1 behind. So when you get down to like the 13th power, I ask you to do x plus y to the 13th power, what row of Pascal's triangle do you have to write out?
14.
The 14th row, right? So whatever this power is, we always have one more term in the expansion. Put a little asterisk by this. I will ask you to refer back to that. That is kind of some checkpoints as you do on these problems. So we can also find the coefficients, or what I call those missing numbers. Once you have the pattern down, start one of your variables at the highest power, and it's going to go down by 1 to the very end. The other one starts at 0 power and starts to increase, or you can start at each end and crisscross them, however you do it. But I said on the very first example, what are the missing numbers? And I was saying they came from Pascal's triangle. Well, you can do your combinations, it's called. Remember doing permutations, combinations?
Yeah.
So 8C3 of us, we'd probably just run to the calculator, put the first number in, 8. Hit my math button, slide over to the probability menu. There's our NCRs, NPRs, factorials. I'm going to do number 3, which is the NCR, and it was 8C3. And it tells me it's 56. What's 8C0?
1.
Right. Now, as you write out the binomial expansion, we can have lots of terms written down. And so this is kind of a vertical notation. It just saves space. It still means 12C3. Combination. All we're doing is getting numbers. These are the missing numbers in the expansion. You can use Pascal's triangle to get those missing numbers, or you can use combination. What's 12C3? 220? And 6C1? 6. Yes, we will, yes. Always do combination. What do you mean? What do I mean?
Do I count down this before? Should I know what combination is?
Yes. Here's what a combination is. Here's a little math rule right there. It says NCR is equal to NC M minus R. How many, we all have that friend, or at least I did. I'm sure you guys probably did too, that you were just embarrassed to be around. Like you have a circle of friends, and it's like when that person asks you to go to lunch, you kind of dread it because when they walk into like Subway, if I order a ham, turkey, and cheese sandwich, right? That might be similar to, okay, at Subway I have 12 choices, right? And I choose to put 3 of those toppings on. Remember combinations, the order doesn't matter. Because if they put the cheese first, then the ham and the turkey, or the turkey, the ham, and the cheese, it's the same sandwich, right? So order doesn't matter. So that embarrassing friend, what do when they walk up? They go, I don't want onions, I don't want peppers, I don't want roast beef, I don't want... They say not, I don't want
See what you
9
want.
of these things, right? So that's why